Alright, ladies and gents, this is Wharton back again with 2.7 parent functions and transformations. I know I had a little time off the last couple videos, but here I am back and better than ever. Let's get going. There are three parent functions that you'll need to know for this section. We got to understand what a parent function actually is. Well, actually, let me plug my tablet in because apparently I did not do that yet. So, let me do that right now. Fantastic. Hopefully it works. You... No? Yes? Alright, there we go. Okay. Fantastic. That was a good 25 seconds of your life you're never going to get back. Parent function. This is the function that all functions start with. Okay, so there is a parent function for every function that we have, right? We have quadratic, we have absolute value, we have square root, and remember from Algebra 1, okay, even in junior high when you started graphing, we talked about this thing called a linear function, which was a straight line, right? The basic function of linear was y equals x. Alright, so we have these parent functions for every single function that we possibly have. Okay, everything that is linear, okay, remember linear is y equals mx plus b, right? Everything that was in this form started by this. Maybe we moved it up 2 units, and then we had the slope was, you know, maybe it was a little steeper or a little fatter. Or lower, whatever. So everything starts from y equals x. And the same goes here for quadratic, absolute value, and square root. Everything starts with these three different types of functions. For quadratic, this is what it looks like. This looks like a parabola. This is what it's called. A parabola. I can't spell parabola if you want to know like the easy way to spell it. That's called a parabola. This is a U. This is a U shape. Okay, this is a U shape. And you can see we have this thing here. Let me use a different color here because I don't think that black is going to work. There we go. Let's use the yellow. That yellow, which is now I'm going to turn black now, this is called a vertex. This is called the vertex. Okay, and then these other points, let's go back to yellow. These other points are what we use to graph this U-shaped graph. Okay, those are 5 points in total. We use this awesome strategy when graphing quadratics. We use this rule of 1, 3, 5. So we use the 1, 3, 5 rule. When we get into graphing quadratics in section 4.1, or whenever we do this, we're going to learn about this rule of 1, 3, 5 and how easy it is to graph quadratics. Okay, the parent function of a quadratic graph is y equals x squared. Okay, every quadratic function that is a U-shaped comes from this equation, this parent function. Okay, absolute value is the next one. You might remember what absolute value is. It's the distance from 0. That's if we're just finding the absolute value of a number. But we can actually graph the function in this form. So y equals the absolute value of x. Again, this is our parent function for every absolute value equation. This equation is a V-shape. It's a V-shape. Again, we have this thing right here, which is called our vertex. In the same fashion that the quadratic is called the vertex, the same thing here. When you have a V, okay, whether it's like this or like a little house, that point is your vertex. Okay, we will get into how to graph this actually in the next section, I believe, and how to actually graph these. The last one that we're going to talk about is our square root function, which is the y equals the square root of x. And you can see that this is only one piece, where it starts right here, and then it continues on in that direction. What's pretty cool about the square root function, I'm going to delete everything else here, so hopefully you have that down, is if I took the quadratic function, so let me draw it on the same graph here. Let me do it in pink. If I took the quadratic function, 1, 2, 3 here, here, and here. So if this is my quadratic from the first one here, all I did was just draw it over here. If I took this and I took it and I laid it down, okay, if you rotated it and laid it down, you would actually get this function. So this little piece in here, the pink one, actually becomes this awesome blue one. Okay? And then this piece here, when I flip it, that actually should become this function down here. But this piece of the quadratic, when I flip it, actually doesn't exist. And the reason is because these are going to be negative numbers, right? Like the square root of 1 obviously is 1, not negative 1. And so that's why it doesn't exist. So that's why only when I flip that quadratic down, only half of the function actually follows suit. We'll get into that more when we get into what we call inverse functions. Okay, that's later on this year. But again, we have our parent function here. Now, with these parent functions, we have specific values that determine where the function moves left, right, up, down. If it's skinny, or let's say in this case, if it's fat, or if it's skinny, or if it's upside down, okay, or fat and skinny, and so on. And where we come up with these is right here. That's what goes in these boxes. This is our movement, I guess, if you want to say your, this is the general form. This is our general form of a quadratic. This is the way it is written. It's going to have a lot of variables here, and that is okay. We're going to talk about what they mean below. So we have y equals a parentheses x minus h squared plus k. We will talk about what the a, what the h, and what the k mean down here. Okay? In the absolute value, we have the same general form. Same thing, but we got to make sure we understand how to write it. So it's y equals a times the absolute value of x minus h plus k. Again, a, h, and k, we're going to talk about those down here. For the square root, we also have a general form. If you haven't noticed, we have these for every one of them. Y equals a times the square root of x minus h plus k. The x minus h is in the square root. So we have the a, the h, and the k, and we'll talk about those down here. Every single function, linear, quadratic, cubic, absolute value, square root, logarithmic, exponential, that's all pre-calculus stuff, but we'll get into the general form in those specific instances when you guys take pre-calculus. So let's go talk about what those three variables actually mean and what do they do to the function. So, what do they do? Well, the a value is what we call the vertical stretch or shrink. What does that mean? Well, that means that if a is bigger than 1, so if the a value is bigger than 1, okay, then we're going to have a vertical stretch. That means the graph, so this is our general absolute value graph. If I have a bigger than 1, that means the graph is going to be skinnier. Okay, skinnier. We're stretching it long ways. We're stretching it vertically. Okay, we're stretching it vertically. If a is less than 1 but bigger than 0, so like 1/2 or 1/3 or 1/4 or 2/5 or, you know, 2/9, whatever like that. It's a fraction that's bigger than 0 but less than 1. We have what we call a vertical shrink. What that does is if I have my general form here for absolute value, if the a is small or a fraction, the value actually is going to be flatter. Just think of it. If I sat on a function, okay, I'm shrinking the function, making it flatter. Okay, that's what a vertical shrink does. It makes the function flatter. All right? What else does the a value do? If the a is negative, then what we have is called a vertical reflection. So if I had the absolute value function here, it's just easy with my two hands to make a V instead of like a parabola or whatever. If I have my absolute value function here, okay, and I want a vertical reflection. Now a is negative. I'm going to take this function, and now it's going to be upside down. And the same thing with the parabola. If you have your parabola, and now a is negative, now I have my parabola upside down. Okay? If I have my square root function that kind of looks like this, okay, if I have my a is negative, it's going to be harder, but now it's going to look like this. This is pretty hard. This is kind of hard to do. I don't have that motion, and I broke my wrist a while ago, and I got metal plates and steel screws in there. I don't know, titanium stuff. It's crazy. I'm like the Iron Man up in here. Okay, so it's like upside down. All right, that's the A. That's all the A does. Okay, we'll talk about that in a little bit, but that's it for the A value. What about the H? The H is the horizontal shift. It's the horizontal shift, okay? Left or right. Right? Horizontal is left or right. And so if H is positive, we got to think this in our brains right now. If H is positive, I'm actually going left. Going left. If H is negative, then I'm going right. And some of you are like, wait, what? That doesn't make any sense. If it's positive, I'm going left, but if it's negative, I'm going right? Well, we got to understand this. Whenever we have horizontal shifting, technically, I'm going to be honest here, technically, if this is my general form of my absolute value, we have parentheses in here. Technically, when you get into pre-calculus, we're going to learn about another value. It's called a B value. That B is a horizontal stretch or shrink. Whenever you're doing something horizontally in these functions, it flips. So the value is opposite. So whatever the number is there, it's opposite of what it means. So if it's negative, instead of going left, usually negative is associated with left, we go right because we flip it out. We opposite out. Okay, horizontal is always opposite. This K value is our vertical. Okay, vertical shift up or down. Vertical, you do exactly what it says. No flipping, no switching, no nothing. Okay, no. Just do what it says for vertical. Horizontal is where you flip. Okay, horizontal is where you flip. Let's use this information now in our examples down below. Okay, so we have this here. All right, this is just an example of what it looks like in our instances. I'm going to give an example of each of these, and so we can see these. Okay, so here's a quadratic. Remember, this is our quadratic. You have to be able... I can't spell. Quadratic. Quality assurance. Hopefully you got that quote from The Office. Okay, I'm watching that like for the 85th time right now. This is quadratic, right? This is our absolute value. And this is our square root. Okay? So for quadratic, for instance, let's do this. Let's say y equals negative 3 parentheses x plus 2 squared minus 7. All right, our absolute value, we're going to say it's y equals 2 absolute value x plus 3 plus 4. And then for our square root, we're going to say y equals negative square root x minus 6 and then plus 2. Right, now, we're going to use everything there to determine what we're doing. You can see, obviously, it's all written there. Okay, it's all written there. But now we're going to apply it into these specific problems. These are not in your notes. You have to write these down. So here we go. What does this number tell me? This is a vertical. This is our k value, first off. This is our k value, right? The k, the k, the k, the k, the k, the k. It's all the k value. The number at the end is the k value. So what is this? This is a vertical. Vertical what? Vertical shift down 7. Okay, right here. It says it right there. If shifts up or shifts down, positive or negative. That's what that last number does. So let's go all of it. This one, number 4. This is a vertical shift. Which way? Up 4. What about this one here? A vertical, I'm going to say a vertical shift up 2. Okay, pretty simple, right? That last number is always your vertical. Pretty easy. Okay, now let's go into the horizontal, the h values. That is this. I'm going to change color so you can. Okay, I can do some color coding. Okay, these are our h values. You take the sign in front of the number, and that tells you if it's positive or negative. So this is a positive 2, positive 3, negative 6. Remember, the b value, or I'm sorry, the h value, not the b value. The h value is your horizontal. It's the opposite. Okay, so this tells me here I have a horizontal shift. I don't want to leave that as an abbreviation for HOR. So I'm going to write horizontal. Shift. This is a plus 2. So it's opposite. So I got to go left 2. Got to go left 2. This one here. This is telling me that this is a horizontal shift. This is a plus 3. So I got to go left 3. I got to go opposite. Opposite. Oppo. What? I can't even rap. I was trying to do some rapping or some beatboxing or whatever. Like, that ain't gonna happen. I got no rhythm. I just sing like, I don't even know, like old school stuff. I don't even know, like old school rock and roll was good to go. This one here, horizontal shift. Which way? Well, that's negative now, right? Negative. That means now we got to go right 6. Right 6. Okay, we got to go opposite. So make sure we understand that horizontal is opposite, no matter where it is. Horizontal, always opposite. Always. Okay, let's go different color. Let's go pink. Let's go pink. Takes a man to use pink. Let's go. Just kidding. Anybody could use pink. Okay, I got some pink shirts too. Let's go. All right, so let's go here. This is our a value, the number in front of the parentheses, the absolute value, or the square root. That's the a value. So the negative 3, the 2, and hopefully you see that this is really a negative 1. Okay, it's really a negative 1. You don't have to put the 1 there if you don't want to. You can if you want to. You don't have to if you don't want to. I usually don't, but for the sake of the video, I'm going to help you out. So what does the h do, or what does the a value do? Sorry, what does the a value do? This is a vertical stretch, right? Because it says bigger than 1. Numbers bigger than 1. Numbers bigger than 1. But then it's also a vertical reflection because it's negative. Okay? Because it's negative. It's negative. So this graph here will actually be upside down. And because it's 3, it's going to be pretty skinny. It's going to move left 2 and then down 7. That's what's going to happen to that graph. This one. What is this going to do? This is just a vertical stretch by 2. Vertical stretch of 2. It's not negative. It's not negative, so it's not flipped. So it's just a vertical stretch. Okay, I'm actually going to come to this one. I'm going to change it a little bit. I'm going to make this negative 2/3. Make that negative 2/3. Okay. Let's look at this one. What does the new value do? This is a vertical shrink. Because a shrink, remember, it's less than 1, greater than 0. I don't care about the negative. If it's negative, that's fine. What does the negative tell me? The negative only tells me that it reflects. So now I have a vertical reflection. So I got a vertical shrink because the fraction is smaller than 1 but bigger than 0. I got a vertical reflection because it's negative. Okay? We got to put all of that together. AHK. 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 What is it? Oh, AFK is away from keyboard. If you guys are gamers or whatever, AFK is away from keyboard. But we ain't away from the keyboard right now. We AHK. I don't know if you can come up with some sort of AHK. Always hyping the keyboard. Always hyping the keyboard. I don't know, I'm just kidding. I'm not very good at that kind of stuff. Okay? If you got something, you email me, let me know. Alright, but that's it for this video. You got some practice, some worksheets in Canvas and ready to go for everything else. Let me know if you got any questions, but Wharton out. Deuces.